M5C2 test circular motion question 7. A child's playground swing has a chain length of 2.4 meters. A child of mass 28 kilograms is released from a displaced position that causes the chain of the swing to be horizontal. Calculate the support force on the child at the lowest point of the swing. Well, the support force is going to have to support the child's weight, and that's going to be mg, plus the force required to hold the child in a circular motion, and that's going to be mv squared over r. The missing piece of information we have is a value for the velocity of the child, and that can be calculated using conservation of energy because the child is lifted to a point where the chains of the swing are horizontal, parallel to the ground. Then that must mean that the height that the child is lifted, the vertical height, is the same as the radius of the turning circle, as in the length of the chains of the swing. So what I can do is join together mgh onto a half mv squared. The m's cancel and I can rearrange to make v the subject, and that would be equal to 2gh square rooted, and the height in this particular case is the same as the length of the chains on the swing, which is the same as, so I'll just put lowercase r, h is the same as r in this case, so that's going to be the square root of 2gr in effect. And when I pop that into this equation, I end up with the force required by the chains at that lowest point is mg plus, and what I'm going to end up with is v squared, so I'm squaring this entire section here, that will get rid of the square root, so I'll be substituting in 2gr, so m2gr, and then I've got r divided by r, so the r's would cancel, and I'm literally left with mg plus 2mg. So all I really need is the mass of the child and the Earth's gravity, and that would simplify to 3mg.